So, if you look at the projects for 152, there's schedule here. The first thing that's due is Splunk 1. And this is fantastic. This is why I learned Splunk, because of this. It was a CTF Splunk put out, and I thought it was wonderful, so I built it in my classes. So, you go to the projects, and you go to Boss of the SOC. That's what they call it. And this is where I was talking before. I said, you don't have to necessarily do things you might not like the final exam. You can get extra credit. So notice, 80 points are required, and there's 245 points extra you can get too. So that's what I mean. There's a lot of extra credit available in this class if you just want to do more hands-on projects, which is perfectly fine because that's the most important thing. Although the stuff in the textbook is fine too, but most students would rather do hands-on projects. All right, and one student's already begun doing it. Good. All right. And so, by the way, what I expect you to do is just 20 points worth each week for the first 4 weeks. It doesn't really matter which ones you do. You don't have to do them in order or anything. If one is hard, just go on to the next one. But I will demonstrate how to do them, and there are hints. So the point of this is, all right. So I have set up 2 servers in the cloud running Splunk with the data already on them. So you don't need to install anything, and you don't need any special operating system or anything. All you need is a web browser. So Splunk 1 or Splunk 2, I'm going to use Splunk 2. When you connect, there's a name and password to get in, which is Student 1 and Student 1. It's not particularly secure. It's just to stop automated attacks. And it's not perfect. One of these servers was trashed this morning, so I restored it from a backup. They do get trashed now and then, but they stay up long enough to get the job done. Student 1 and Student 1. They're both the same. The only reason I have 2 is just so that a lot of students can use them at once. All right, so when you get in, Splunk is a commercial product. It is an SIEM system, Security Information and Event Management System, and it is called Google for log data. That's all it is. And the only thing we are going to use is this thing here, search and reporting. All this other stuff we don't need. So if you go to search and reporting, now you just have a place where you can type in a query and search the log data for things, and that's all Splunk is. It's just a search engine for log data. Believe it or not, it is at least a couple of years ago, it is the 4th highest paying company in America, and they are rolling in the dough, and all of the Fortune 100 use it, and they pay tons of money for it. It seems simple. It's in fact wonderful and luxurious, and the cheap competitors are much harder to use. So when you get tired of wasting your staff's time on a hard-to-use product, you pay for the best, and your staff gets more done. So, all right, so this has some data in there. You see it has almost 1 million events, 955 events. These events are items of log data from devices. What you do is you put an agent on every device, every firewall, every server, every endpoint, your everything you have. You put an agent on there, and it sends its logs up to a central collection agency, and that sends it up here to search. So instead of having to go to devices and get the logs off them, it's all in one central place. The data summary will show us what kind of data it has. Now, the default tab sorts it by host name, which is an arbitrary name assigned by the company, which might mean something to you if you're inside the company, but it's not very useful to us. So the source types is probably the most interesting view for us. Here you see the types of data you have. Windows event logs from your Windows machines. That makes sense. That's an obvious thing to be in there. Here's registry data from Windows machines. Here's more Windows. This is Sysmon. Sysmon is wonderful. Sysmon is a free tool you add to a Windows machine, which creates special log entries that are much easier to understand than the default log entries. If you looked in Windows event logs, they tend to be very, very noisy. Like you just open a folder and open a file, and you've got 100 log entries from that. This has just 10 or 12 types of logs, and they are really simple, easy to understand things like registry key changed or a process in it launched or something like that. Then you got a FortiGate firewall that's got a few logs. Then you have a Microsoft Web Server, IIS, Internet Information Server. I don't know what this Nessus stuff is. Then you have stream data. If you used Wireshark can sniff network and get all the packets. That is not what Splunk does. Splunk can also sift the network, but instead of recording everything about every packet, it records a summary of the flows, as we're going to see. And it's looking for the common protocols like DHCP and HTTP. We're going to mostly look at HTTP stream data today. And then you've got Suricata is an intrusion detection system, so it's sending log entries up here for recognized malware on the network. So that's the data you have. And of course, what happened here is to prepare this, Splunk hired some of their employees to set up in the Amazon cloud a whole company network with like several servers and all these things, and then attack it with various tools and collect all the incidents and prepare this for us to play with. So that's the setup. And now, technically, it all has an index called BoTS v1. In this case, there's only one set of data, so you don't even need to specify the index. In an enterprise class environment, you might have multiple locations and multiple subnetworks, and you might label them with index values to tell them apart. But anyway, so this is the first one, is you specify the index and you search. And when you search, you find nothing, 0 events. Because by default, Splunk only looks for the last 24 hours. And this data is like 6 years old. So you have to change this to all time. Now, if you search for all time, it's going to find all 1 million events. Now, that's going to take a long time. So what you do, and what good is 1 million results? So if you have too many results, you go to sampling. I'm going to make it 1 in 100. Now it's going to just give me a random 1% of the events. This is how you get an overview of a group. And it'll be much faster. The speed of Splunk is mainly determined by the number of results it finds. So now it found 9,609 events out of the 900,000 events that were there. And here's what an event looks like. The individual log entries show up down here, and the fields show up over here. So there's Microsoft event logs in there. And there's a thing here called Event ID, which you'll know if you've done Windows Tech Support. The Event ID, there's a number that tells you what kind of events. And you see there's Event Type 7, there's 1,600 of them. Event Type 3, there's 1,000 of them, and so on. All right, so that's an overview of what's going on here. All right, and so now we're going to look at Stream HTTP. And I'm just going to choose it. I could type it in, but you know, there is a mouse. This is why you paid for the thing. If I go to a raw search and I go to data summary, I don't have to type things. I can choose them with the mouse, and then I don't have to worry about misspelling them. So if I go to source types here, where we were before, there will be Stream HTTP, and there it is. There are 23,000 events of the 900,000 that are this type. So if I just click on that, it will just type it in for me. Source type equals Stream HTTP. And now it's searching. But again, since I'm started with a clean search, it went back to searching only over the last 24 hours. So I have to set this back to all time. And now I know there are 23,000 of those. And I'm only sampling, I guess I'm not doing any sampling, so I should see them all. So when it's done, I should see all 23,000 HTTP requests here. All right. And you see down here an HTTP log entry. And right now it's broken up into fields. So here's the port. Here's the 200 OK, the status method. There's the password or something. That's one way to look at it. I prefer, whoops, bad thing happened. All right, I prefer to view this in list rather than table. Then you see the data like this, which I find more useful. All right, so now if you look through this data, you will find, usually, pretty easily, some malware, because this data is mostly attack traffic. Let me just check and see if I skip. Oh, yes. We know the domain name of the company. The company's domain name is I'mReallyNotBatman.com. So if I want to see data to my own web server and not just all the web data, I would add this. I want to see log entries that contain that string. So HTTP data, and I just put this in the way you would in Google, another string. Now it will also have to have that domain in it. So instead of 23,000, I better get a lower number. There, 5,000. Yeah, it's not done until you see the green check mark. Yep, 17,000, 22,000. So not that much other data in this database. But anyway, this is the data going to my web server. Now, I think this is where I expect to find malicious attacks. Yep, okay. If I just scroll down here, here I have, notice this. This is obviously a malicious attack. Look at this weird stuff. It's going to a PHP page, and in the search word, it's putting in select from, select sleep, select sleep, select from, select sleep. This is an attempt to perform SQL injection, if you're not familiar with it. It's trying to inject commands into a field that's supposed to contain data. So this is an attack. Most of these are going to be attacks. If we go down and look at some of the others, this one here, it's not obviously an attack. Might have been something there. Let's see what else we got. Yep, here's another one. Select, sleep, select, all that stuff that shouldn't be in something that's supposed to be like a file name or something. And you'll even see Joomla search injected by AVS. Ordering category, and it looks a little fishy. Let's see if we got anything else nasty down here. Here's something interesting. User agent, Acunetics product, Acunetics web vulnerability scanner, free edition. So the reason why we see so much traffic, and so much of it is attack traffic, is the bad guys ran a vuln scanner. And they got a free edition. So they ran a vulnerability scanner, and vulnerability scanners just send thousands of attack tracks everywhere on the web page trying to find a vulnerability. So it's really noisy, really obvious, and that's what the bad guys did. So now that I've found this attack traffic, I can answer several flags. So if you go here, get rid of this garbage. There. So there are flags. The first thing is the brand name of the vulnerability scanner. Well, I found that. It's Acunetics. So I'll copy this into the clipboard if I can get this thing to cooperate. Copy. All right. So now when you find a flag, you put it at the top of this page. Submit flags. You got to know which challenge it is. This is 1.1. Let me go down to show you. Okay, 1.1. All right. So challenge 1.1, my name is the special name that won't show up on the scoreboard. And I put in the flag and submit it, and that's correct. And so I will now have points in the scoreboard. And as you see, somebody's already done it. Now, I don't show up on the scoreboard because I used that special name, but I could still see it if I used the special scoreboard. Anyway, that's the point. And so that's what you got to do, is find flags and put them up. And I'm just going to talk about a few more of these, and that's all I plan to show you today, but you can start doing this. So next thing is elite speak domain. Oh, wait, that's the wrong one. Okay, next one is the attacker's IP and the web server IP. Now, I should be able to figure those out from this one event I found. Here is something coming from the vulnerability scanner. That must be from the attacker to the web server. So all I have to do is figure out the source IP is here, so that's the attacker. And this is information you'll want to keep and remember. I'm just going to put it someplace like here, attacker. Whenever you're doing a pen test or anything like this, you keep notes. That's the attacker's IP, something starting with 40. All right, and the destination must be the web server. And that would be destination IP. This must be the web server. So that's the next couple of flags. And you're going to need those in the future, knowing the IP address of the web server. Web server. There. All right. And now I want to find the defacement file name. And this is where you begin to see how good this is. Now, remember in that lecture, I talked about a company where they had all this data coming in, but as soon as they got a good SIEM system like this, they were able to immediately notice that the same user was logging in twice from different physical locations. That's what you need an SIEM for. You have a million events. How do you find the suspicious ones? Well, this is how. We're going to find traffic that went backwards through the network. Now, a proper network is designed so servers can only be servers. You should not be able to open a browser on the web server and go to the web and download something. There's two reasons for that. The first reason is you might download a malicious thing and infect the server with malware. If you need to put a file on a server, you should download it on a workstation, scan it for viruses, and then move it over with a file share or something. The second reason, and more important, is if you watched Caitlin's hacking demonstration in 123 today, you've seen this. Attackers typically use a reverse shell. The first thing they do when they get the ability to run code on your system is run code that will call out to the command and control server and put you under remote control. So they will try to initiate an outgoing connection from your server, and you should not allow that. Your firewalls should be configured to prevent that. you should only allow incoming requests to the web server, never outgoing requests from the web server. So here's a question. Did the web server make any outgoing HTTP requests? Now right here, I've got a list of all the HTTP requests, but I can filter them by source IP. So if I go down here and look, here's say source IP. Well, all these are coming from one of these two sources, and that's fine. Neither of them is the web server, so these are okay. But I want to filter, see if something ever came out from the web server's IP, and that is this 192.70 stuff. So I clicked on that just to get the format right so I don't have to type anything. And now I'm going to replace the IP address with the IP address of the web server. Now I'm going to get requests that came from the web server going to a website. This should not be allowed by the security policy. Now I got 0 results, but that's because I still have the domain name here. Now the outgoing requests will not have this domain name. They will have some other domain name they're going to. So I need to take that off. And now, out of these 1 million events, I have found the 9 malicious ones. That's why you pay a pile of money for this product and you train your staff to use it. That's really impressive. I got 8 bad events out of 1 million, and it was that easy to find them. These are events that went backwards through the network. And now there's only 8 of them. I can just look at them one by one and see what they're doing. This one is calling out to get Poison Ivy is coming for you Batman.jpg, downloading malicious JPEG, which they're going to use to deface the server. And it's going to this weird website called prankglassenebracket.jumpingcab, and it's on port 1337 instead of a normal web port, which is a traditional port hackers use. So once again, that's the next few flags. The next few flags where I think what's the name of the image, what's the name of the image, and what's the domain name. Now, and I think we'll just pick up next time. That should get you started. And you can keep going beyond this, of course. But you should start using Splunk. Splunk is great fun. And the only thing, Splunk is a well-designed product. The thing that makes it difficult is not Splunk, it's the structure of the log entries themselves. You have to get used to the way log entries look. But the Splunk tool has gone as far as it can to make it easy for you to look through those log entries. So I'm going to stop the recording.